Hey, group one. All right, so you are going to be doing this first equilibrium problem. What we are ultimately tasked to do is determine the forces acting on the support structure. So we have to find F1 and we have to find F2. And the way to do that is obviously through our two different equations that require, or that equilibrium requires. And that is that all of the torque around pivot point A and the torque around pivot point B have to add to 0, and all the up forces added to all the down forces also have to add to 0. So there's a lot going on in this problem, but if we take it slow and if we use just our very generic basic ideas of torque and forces, we should be able to solve this without too much issue. So I'm going to just clear those. First of all, the first thing that we know is that our forces that are going down are three of them. There's three of them. There's the 300 Newton force, which is trying to make that object go down. There's the 100 Newton bridge itself, and there's the 500 Newton force making that one go down. So our total downward forces, 300 plus 500 plus 100 is 900. So our total down force is 900, and since we have two upward forces, F1 and F2, our total up force, F1 plus F2, have to equal 900. Could be 450 and 450, it could be 400 and 500. We don't have enough information yet to determine. That's where the torque comes in. So we know that the total torque has to be 0. I'm going to come back to F1 plus F2 equals 900 in a little bit, but let me clear that out. We know that the total torque has to equal 0, and remember from class that when we're dealing with the torque, we want to look at the torque from object A independently from the torque of object B, but ultimately we're going to end up adding them together. Torque A plus torque B. My cat's having fun over there playing with the curtain. So torque A, the torque around object A, what we do is we think of B as not being there. And when we do that, we get four different forces acting. We've got a force of 100 newtons acting down at the center of mass. We've got a force of 300 newtons acting down at 2 meters away from pivot point A. We've got 500 newtons down at 2 plus 5, which is 7 meters away from pivot point A, and we've got F2 that we have to set up. So I'm just looking at point A. Obviously, F1 doesn't have a torque because the lever arm is 0. So relatively quick, our torque around A, remember clockwise is going to be positive. So we're going to have 2 times 300. From this 300 Newton force, we have a lever arm of 2 meters, 300 Newton force going down. That's a clockwise. Plus, the center of mass is going to be halfway. This whole thing is 10 meters. So it's going to be at the 5 meter mark. So 5 meters away from object A, so 5 times 100, plus 500 is 2 plus 5 meters, so its lever arm is 7 times 500, plus we do have a counterclockwise from F2. We don't know what it is, but we know it's 10 meters away, plus, but really this is going to become a minus, because it's F2 is making it go counterclockwise. So it's minus 10 times F2. So that's our torque around A. And what the torque around A is, it's going to be 600, which is this one, plus 500, which is that one, so that's 1100, plus 3500, 7 times 500 is 3500, so that's 4600 minus 10 F2. This is our torque around object, or around pivot point A. 4600 minus 10 F2. I'm going to clear that out and just rewrite it right here. Torque around A is 4600 minus 10 F2. we've got to do the same thing for torque around B. So I'm going to pretend that A is not there, and all the clockwise are positive, all the counterclockwise are negative, but we're still using the 300, the 100, the 500, but we have different lever arms because now we're focusing on this pivot point, so our lever arms are going to be different. And these 300, 100, 500 are also now making it try to go counterclockwise when you forget about A. It's rotating around B counterclockwise. So those are all going to have negatives. So the 500 is 3 meters away from B. So it's negative 3 times 500. That negative again means the counterclockwise. It's still 5 meters. It's at the center of mass. Minus 5 times 100. Minus the 300 is going to be 8 meters away. So minus 8 times 300. And then now the F1, which is 10 meters away, is going to be plus because F1's making it go clockwise. So plus 10 F1. And when we simplify that, we get 1500 minus 500, so that's negative 2000, minus another 2400, so minus 4400, plus 10 F1. So we get the torque around B equaling negative 4400 plus 10 F1. And this is important. These two things right here. It looks like a system of equations, but remember that for balance, we have to have all the torque around A and all the torque around B have to equal 0 when added together. So we're actually going to simplify that. So we get 4600 minus 10 F2. That's just torque around A plus negative 4400 plus 10 F1. And that has to equal 0. So 4600 plus negative 4400, let me just go over here so I'm not on my picture, is a positive 200 minus 10 F2 plus 10 F1 equals 0. And I'm going to simplify that just one more step. I'm going to, let's see, I want to add, let's get a green so you can see the difference. I'm going to add 10F2 to both sides and subtract 10F1 from both sides at the same time. So I'm going to get 200 equals 10F2 is going to get added to the other side minus 10F1 on the other side. And then my final step, factor out the 10. So my ultimate equation that relates F2 minus F1 is that 20, so all I did is factor out the 10, so you're going to get 10 F2 minus F1 in parentheses, and then divide by 10, so I'm going to get 20 equals F2 minus F1. And this is key. So, remember this equation, 20 equals F2 minus F1. I'm just going to clear out to get some space, but you should be taking notes on this. We're almost done. I had two equations that dealt with forces, F2 and F1. First of all, F1 plus F2, remember when we were first talking about it, had to be 300 plus 100 plus 500, so 900, because all the down force has to be canceled by the two up forces. So F1 plus F2 equals 900. But we also got that F2 minus F1 equals 20. That was the last one we got, and that just came out from when we were dealing with the torques. So, a lot of you will be able to do this in your head, but really what we can do is just solve the system of equations. I'm just going to rewrite this bottom equation, this top equation. I'm going to rewrite it as F2 plus F1 equals 900. Didn't do anything different, didn't change it, just switched because 4 plus 5 is the same as 5 plus 4. And that way we have it a little bit more organized. And there's a couple different ways you can do this. Solve the top equation for F1. So F1 equals 900 minus F2, and then plug that in here and solve for F2 and then plug back in. Honestly, I can do this one in my head, and I think a lot of you can too. when you subtract F2 and F1, so F2's got to be a little bigger, and they have to add to 900, so they're roughly 450. So one of them is going to be 460, and one of them is going to be 440. And again, system of equations, this is a math thing. I can help you in class if you're struggling with that. But 460 and 440, really, honestly, if you get to this point, these two equations, you're golden. That's really where the physics stops and the math begins. And remember, this is a physics course. So you get 460 newtons and 440 newtons, double check. Add those two together, you get 900. Subtract F2 from F1. 460 minus 440 gives you 20. So the force that F2 has to push up with is 460 newtons, and the force that F1 has to push up with is 440 newtons. Now, the problem you have accompanying this video is not obviously these same numbers, but it's the same process. I'm going to keep a lot of it the same, as you will see, and have been seeing, but some of the numbers are different, so you're not going to get the same values, but I want you to use this video as a guide. So what you're going to do, you are responsible for this problem. Tomorrow in class, you're going to meet with all the people who had problem 1, and then you're going to mix into different groups. I'll tell you what groups you're going to be in, and you're going to basically teach the others how to do this type of problem, and then vice versa. They have a slightly different type, and they're going to teach you how to do that problem. So you're going to be teaching each other, and it's just a really effective way for the learning. So hopefully this helps. I would recommend that if you were a little unsure, go back, pause, rewind. You really want to come into class tomorrow understanding this because you're responsible for teaching this to the students. I will also be available tomorrow night or tonight to help you. But hopefully that helps, and hopefully you can see the logic of balancing the torque, balancing the forces to ultimately solve a relatively simple system of equations. All right, great job. Thanks.